Welcome back, Leo Lions. This is Mrs. Morgan with today's lesson over volume of prisms. So what in the world is volume and what in the world are prisms? We've done some work with prisms. So the definition of a prism is basically a three-dimensional shape where the lateral faces, so the shapes around the outside of this shape, the back one, this side, they are all rectangles. When all of the lateral faces are rectangles, that's a prism. Then we identify prisms based on their shape that they are sitting on. So the base shape in this first example, we see a rectangle. So we call this a rectangular prism. Now the next example, the base shape, now this is again a prism because there's three rectangles on the sides. So lateral faces that are rectangles, it's a prism. But this example, the base shape that it's sitting on is a triangle. So this is called a triangular prism. Now, not always is a 3D shape sitting on its base. I could take this triangular prism, turn it on its side, and then sitting on a rectangle. But the definition is the lateral faces are rectangles, and then the other shape identifies how we name that prism. So it'd still be a triangular prism, even if I turned it on its side. Okay? Now, volume. What is volume? Volume is, and I'm going to have you guys write this down on your notes, volume is the amount of space, and that's inside of an object. So amount of space, and lost my pen there. There we go. Amount of space inside, and we're talking about 3D objects. Inside an object. And there we go. Now you can see the whole definition there. So we would want to imagine this prism off to the right here, and if we took some water and filled it all the way to the top. Well, the water inside there, that's what we call the volume, everything inside of an object. So the formula for volume is capital V. We use that for volume. And it's equal to capital B times H. Now, we have to know about this capital B because a capital B is totally different than a lowercase b. So a lot of times in geometry, we see, for like a triangle, we do 1/2 times base times height, and we use lowercase letters. So that would be the base measurement of that triangle, and then the height of that triangle multiplied by 1/2. So the B in that case is a little different than the capital B over here. This capital B, and we're going to write down, represents the area of the base. So if the base is a rectangle, well then we do length times width, find the area of the rectangle, and then multiply by the height of the prism. If the base shape was a triangle, well, like I showed you up here, we'd find 1/2 times base times height of the triangle. So find the area of the base and then multiply by the height of the prism. So volume is capital B times H. And then we have to remember that that capital B changes. So first example, we're going to do a rectangular prism. So let's write down, because consistently a rectangular prism will have the same volume formula because the base is a rectangle. So that capital B is actually going to be replaced with length times width, and then we multiply it by the height. So first step, I keep telling you guys, in any sort of geometry, I would write down what formula are we using, and now let's replace what we know. So over here, off to the right, we have a rectangular prism with 3 dimensions. So I would give one of them the length of the prism, the width of the prism, and then the height. So identify your 3 variables. So our goal is to find that bottom shape, find the area of all of that rectangle, and then multiply it by the height, and then that will give us everything inside that inside that rectangular prism if we were to fill all of that prism up to the very, very top. Okay? So let's replace these variables into our formula. The length is 2.5. The width And remember, all of these are being multiplied, so I'm going to put multiplication symbols in between each number. The width is 5, and then the height is 4.5. And once you have now shown your work, what are we plugging into this formula? Well, our goal is to find the volume, so all we have to do is put 2.5 times 5 times 4.5 into our calculator. So 2.5 times 5 and times 4.5. We get 56.25. So 56.25, and then for volume, we label it with our measurement. So in this case, our rectangular prism was labeled with feet, so we'd label with feet. And then volume is labeled with a cubed, an exponent of 3. So this is cubic feet, where we could fit little cubes inside this prism and see how many cubes would fit inside there. So that's why we call them cubic feet. And the cube would be based around a foot. So volume for that rectangular prism, 56.25. So if you have a rectangular prism, you are simply doing length times width times height. Now, next example, we have a different type of prism because the base shape is not it's not a rectangle, it's a triangle. So we call this shape a triangular prism. So the formula for this, we're going to write down, we want to find the area of the base. The area of the base is the triangle. So I'm going to put in parentheses here, 1/2 times base times height. That is our triangle. And then we have to multiply it by the height of the actual prism and not the height of the triangle. So let's take a look at just the base shape because our goal, we want to find the area of this pink triangle and then multiply it by the height. So this 12 over here, that's definitely the height of the prism. Now, let's take a look inside of our triangle. And here the triangle across the bottom, that 14 represents the base of the triangle. The height then is this measurement in between, that 8. So the 8 is the height of the triangle. So to find the area of that triangle, we're going to do 1/2 times base 14 times 8, which is the height. So that represents the area of our triangle. And then we're going to multiply it by the height of the prism, which is 12. So times 12. And that will give us then the volume of that entire triangular prism. So we could put all that in our calculator at once. Let's find the area of this triangle first. Remember that half, if we multiply by half of something, we're really cutting it in half. We're dividing it by 2. So 1/2 times 14, think of what's half of 14. Well, half of 14 is 7. So 1/2 times 14, and you may want to show this in your notes here, these multiplied equals 7. So then all we have to do is 7 times 8 to find the area of that triangle, which would be 56. So the area of the triangle is 56, and then multiply by the height of the prism, 12. So 56 times 12 will give us the area of the volume of our prism. So we'll do 56 times 12, and we get 672. Now, actually, I do want to show you, if you didn't do that whole part and you did 1/2 times the base was 14 times the height, so there's the area of our triangle, times the height of the prism. I put it all in at once, and notice you get the same thing. It's still 672. But I did that extra step in there just to show you what the area of the base would be. So the volume of this triangular prism is 562. We have it labeled, wow, I do not know where I got that 562. 672. I apologize. See, you can see even your teachers make mistakes. So 672, I was talking as I was filming and I thought, that doesn't seem right. And I want to double check. 672 is correct. And then our label is in inches, since that's what we have over in our diagram. And volume is labeled with our cubed. So volume of this one is 672 inches cubed. So there we go. There are 2 types of prisms. For this year, those are the 2 types that we will stick with. We won't go any further beyond that. And then our next goal will be finding the volume of a cylinder.